So if I put the chemical formula for kaolinite onto the board, it would look like this: Si4Al4 O10 OH8. And if I count up the chemical charge in each of these atoms, so we have 4 silicon, which should give me 16 positive, 4 aluminium, which gives me 12 positive, 10 oxygen, which is 20 negative, and 8 hydroxyl, which is 8 negative. If I count those up, you'll see that actually the net charge is 0. So this arrangement of atoms makes chemical sense with respect to charge balance. But actually, when you look at the mineral overall, because the mineral has edges, that gives the clay mineral a slight negative charge. And it's that slight negative charge which makes the clays have an interesting property chemically when they're in the environment. So, and that chemical property is called cation exchange. So cation exchange happens when I have a clay particle, and let's say I've immersed that clay particle in solution. So it could be in a river or within the particle, the void spaces within a soil. Let's say I've got a clay particle here, and because of the edges of the particle, it has a slight negative charge on the surface. Now that slight negative charge can do 2 things. It can attract water molecules to the surface through a double layer. So we know that water as a molecule looks like this. It's got 2 hydrogen atoms on one side and an oxygen on the other. And that means it's dipolar, so it has a slight negative charge on one side and a positive charge on the other. And that positive charge from the hydrogen atoms is attracted to the surface of the clay particle. So you can get water molecules being attracted to the surface of the clay particle. You can also get cations attracted to the surface of the particle. So things like calcium 2+ atoms within solution, magnesium 2+, and lead 2+. And those can be attracted and sorb onto the surface of the clay particle, onto the exchange sites, so the sites with the highest negative charge. We also know that different cations absorb differently onto the surface of the clays, and it gives rise to something called the trophic series. But we know that your ammonia ions absorb better than potassium, it's better than sodium, it's better than lithium, which is better than magnesium and calcium. If you have cations lower in this scale, it already absorbs your clay particle, you might find that it swaps with some of the cations or the ions higher in the scale. So that's another interesting feature within cation exchange within clay minerals.